Artificial intelligence identifies new music hits. In the future, artists and record labels will no longer have to guess whether the song they're working on will be a hit. Algorithms will help them answer this question. And these algorithms, in turn, will only need a few pieces of information about how our bodies function when we listen to the music. Scientists trained machine learning algorithms to analyze listeners' bodily responses to a specific piece of music. The AI measures the listener's emotions and attention, using their neurophysiological activity as a proxy. This allowed the researchers to predict which songs would be most liked by the most people, with 97% accuracy. The description and results of the research were published in the journal Frontiers in Artificial Intelligence. Researchers at Claremont Graduate University decided to train algorithms to analyze people's bodily responses to the music they were currently listening to. This allowed them to predict with 97% accuracy which other songs individuals would enjoy. These algorithms measured and assessed the emotions experienced while listening to a melody and how focused individuals were on it at that moment. The basis for this assessment was neurophysiological data collected by the algorithms. This proved significantly more accurate than if we simply asked the person whether they liked the song. At the same time, the algorithms didn't need a large data sample to form an opinion. Data collected during just 1 minute of listening to the song was sufficient to achieve an accuracy rate of 82%. 33 people participated in the study. Each person listened to a total of 24 pieces of music. Their heart and brain activity were simultaneously monitored by sensors. Of these tracks, 13 were deemed hits by streaming platforms, but as might be expected, the study participants were not informed which ones they were referring to. After the study was completed, the collected cardiac data were analyzed and used to determine the individual's brain function. This is possible because when we feel good, our bodies release two hormones, oxytocin and dopamine. Applying this to the situation at hand, when we listen to music we enjoy, our brainstem begins to secrete oxytocin. Meanwhile, in our prefrontal cortex, when we are focused on something, e.g., listening to music we enjoy, dopamine begins to accumulate. Analyzing brain responses by examining heart behavior could lead to greater accuracy in predicting which songs will become hits. At the same time, this approach is significantly more effective than those used to date. Previous attempts have included analyzing the functioning of the brain's reward system, but it has clearly failed to meet expectations. By applying machine learning to neurophysiological data, we were able to identify future hits almost perfectly. The fact that the neural activity of 33 people can predict whether millions of others will listen to new songs is incredible. This level of accuracy has never been achieved before, said Paul Zak, co-author of the paper. The enormous potential of the neuroprognostics described above is undeniable. In the context of music, for example, it will be possible to create playlists tailored to our current emotional state. However, this will also apply to other forms of entertainment, such as movies or the entertainment we watch on television. This way, viewers will be able to be provided with the kind of entertainment they expect even before they are even aware of it.